right, so as Roger said, we're going to talk a little bit today about how to architect your cloud. And when we say your cloud, obviously it's how you leverage the cloud. You know, every now and then you may have a private hosted cloud, but for the most part, you're using offsite resources. So actually what we'll talk about more is how do you ultimately drive performance as you're leveraging cloud resources. So I work for SoftLayer. We're an IBM company now. We were acquired by IBM recently. Mostly they're using us as the infrastructure provider that they leverage for their software as service offerings and ultimately their public cloud offering. So their service of VMs, things like that. Specifically, I work for SoftLayer Labs, which was previously called Project Innovation. But we changed our name to be in line more with the IBM naming conventions. So they have the idea of labs, so we became SoftLayer Labs. And what that actually means is that I get to play with all kinds of cool toys. Most of my days I spend looking at new technologies, both actual hardware, software, different offerings throughout the industry. And I actually enjoy my job. I like it. I keep waiting for them to come along and pull the plug. Sometimes it doesn't always feel like work. It's good to be able to just sort of pick something up, take a look at it, and see what it does, what it's good at, what it's bad at. So I get a lot of exposure to a lot of new things, ecosystems, services, and platforms. Kind of an idea of what's coming next. So I think by now most of us have digested the cloud. I've been coming to Cloud Expo for several years now, and it's fun to see how all the different presentations have gone from this is what the cloud is and trying to define it and things like that, and have really moved on to more of what you might consider the evolution of it. So it's gone beyond just a marketing term, and it's become a real thing now. It's an actual deployment strategy, and it's a commodity that's fairly well known and we all understand now. So really, as a provider, we experience the commoditization as, you know, just a way for us to be able to take the known quantity and then embellish it, right? So as a provider, it's more about now what the services are that we provide around it. Your queue services, object storage, and you kind of see that trend now a lot with the providers. It's no longer just about the virtual machines. It's about that entire ecosystem that's around it. So that's continued. We've embraced that along with most of the major providers. So now it's more of what you would call a deployment strategy, right? So we're not talking about what it is anymore or how do we use it, those sorts of things. Now it's more about when do we use it? When does it fit? We'll focus on leveraging its core capabilities, capacity on demand, rapid deployment, things like that. That's really what defines cloud. As I was saying, the services, right? So what sort of API is sitting around it? Those are really the key foundational parts of what a cloud is these days. So as we see applications moving to the cloud, and like I said, with SoftLayer Labs, I get a chance to take a look at a lot of different applications coming in, both as vendors come in and, you know, obviously they want to pitch their application and how SoftLayer might use it, or a customer, they have a great idea. We have several different outreach programs with startups. We have a Catalyst program, so I spend a lot of time sitting and talking with, you know, a couple college guys that have got a great idea and they want to put it on the internet and put it out there available, put it on the cloud, and we offer free services to them, speaking with them as well as infrastructure. So I get to see a lot of these new things coming around. And one of the interesting things is watching how some of them have been slow to adopt the cloud and some have completely embraced it. So obviously a lot of these Catalyst partners, they're born on the web, they understand it, they embrace it. But every now and then you get somebody that is still stuck in the enterprise mentality of things. They're still wanting, you know, large deployments, centralized, things like that. They haven't embraced sort of the scale-out architecture of the internet. So we've kind of got this slide here showing kind of the difference between the enterprise and the internet applications. And this one's fun. This is actually a presentation that our CTO does a lot. He uses this slide, but I like this one myself. This is what I think of when I think of enterprise applications. He looks pretty rough there, kind of scary ostrich sitting behind his wall. Probably is going to ask you for your password to get in there. And the idea here is that it's a known quantity. You've got kind of a walled garden. It's usually on-premise. You know what your scale is going to be. You're probably serving your employees. Maybe you've got an e-commerce site, maybe. But generally, you know the scale of the application and what's going to happen. And it's a planned event. You know, we're going to have to add some more machines, things like that. So when I think of enterprise, this is the sort of thing I think of. But just like some of the vendors that I encounter, sometimes the wall comes down, right? Now you're out on the internet. And as you can see, the ostrich is going to have to move a little there. When you're dealing with a more dynamic environment where you're not exactly completely in control of the scale of it and when the users are coming, how they're coming, you really need to change the way you look at things, right? So this is where cloud really fits in, the ability to be able to say, I don't know when I'm going to need these resources, but I know how I'm going to need them, and I know exactly how I'm going to bring them online. So you design for those sorts of things, and you're able to react to them properly if you've put together a good design for a cloud application. So this is not meant to be a timeline. This is sort of an illustration of what a cloud deployment has started to look like, some of the evolutions as you go along. So the first one there is just representing, maybe you've got a website. It's got the Apache icon, right? So you've got a couple nodes maybe. You're not super interested in DR or HA. It's fairly stateless. You're really well suited for a virtualized instance, something like that. Then you move out, you kind of scale out more to the LAMP stack, right? So everybody's favorite multi-tier application. We have thousands of them in our data center. And what we've done here then is you sort of broke it out, right? You're not just deploying as a static content, possibly website. Now you have a database, maybe some login information, some forms to fill out, maybe even an e-commerce sort of site, but you've definitely got a data layer. So you're starting to have to think about maybe breaking out those layers, using some different strategies on the cloud deployment. And then you move into something more like Hadoop. Hadoop is going to be much more of an ecosystem, right? There's a little bit more emphasis on locality, right? Hadoop is going to be much more latency intolerant. You're going to need to have rack affinity. So putting that on, a commodity virtual provider, putting it out on a virtual guest that may end up someplace in a data center, it's probably not the way to go. So now you're looking at a little bit more sophisticated deployment into cloud. And then we move into something like Cloudant. IBM recently acquired them. More of a similar sort of NoSQL big data solution, but rather than being more localized, now we're talking about one that's going to be more geographically diverse, right? So we're moving beyond the rack, beyond the data center. So once again, the deployment footprint becomes a little bit more complex, and latency between the deployments becomes more important with this. And then you've got something like Mashup, which is sort of a API service composable sort of system, right? So that's on the far end of that complexity scale. So you're putting together different services, orchestrating different applications with it. So you're dealing with a lot more complexity with that deployment. And then we move on to the last one, the Internet of Things, right? So now we're talking about any device participating in your ecosystem, handheld devices, sensor data. They're all over the place. They're coming from any direction. Whereas with something like Mashup, maybe you've got a little more control over your deployment and your ecosystem. This is everything is everywhere. You're collecting data. You're trying to do something useful with it. Maybe you've got techs out in the field putting data in, or you've got sensors running in multiple network operations centers, and you're trying to pull all that data in and make sense of it, sort through your traffic. So this would be by far the most emerging and complex deployment strategy that's out there that we see for cloud. So let's talk about something that I enjoy, performance. I do a lot of performance testing on cloud applications. I'm going to be doing an entire presentation on it tomorrow if anyone feels like getting into the nitty-gritty, nerdy details. I promise you I will put you to sleep. I will try. So this infographic is from a Fast Company article. And it's kind of interesting because it's a very simple use case to talk about with performance, very straightforward. It was an article talking about page load times and abandonment rates. So very specifically talking about how many seconds it took before you started to lose that user with the user experience. It was a great use case to kind of demonstrate performance and its impact on the bottom line. In that same article, Amazon was talking about a 1 second loss in load time equating to $1.6 billion of lost revenue a year. Now, granted, they're an extreme case. They get a lot of traffic. But that's a perfect example of how the smallest little performance inconsistencies can really impact the bottom line. And obviously, Google, same article, had, I think it was a 0.4 second loss in search result time, was a loss of 1.6 billion page loads, which obviously is ad traffic for them. Everybody knows Google loves their ads. So once again, immediate loss in revenue. So this kind of emphasizes how the cloud can either help or hurt with its technology that's been selected, your bottom line, and sort of emphasize the importance of performance when you're deploying your applications. Obviously, it's not the end-all, be-all. You can have the best deployment known to man, but the garbage in, garbage out principle still applies. So you still need to consider design and things like that with performance. But platform does also play in. So I love this graph because I made it for the presentation. Like I said, my CTO usually does this one. I put this one together, and it was an illustration of different sorts of performance and what you're looking for. So what we have here on the top is we ran a NoSQL big data solution, and we ran it on a virtualized instance with network attached storage on the top, and then we ran it on a bare metal server on the bottom. And what you can see there is, although the one on the top does enjoy some peaks of higher performance, it is completely inconsistent. There's no way to really tell what the average performance is, except for there happens to be a line kind of through the middle of that big swarm of bees that's flying along there. And then on the bottom, literally with a few outliers, it kind of makes a nice, even, straight line. This test was a steady amount of traffic being fed into, like I said, a NoSQL big data solution, a document store. So it sort of helps highlight not all applications are right for a commodity deployment. You need to sort of pick where you're going to put them. Obviously, if you've got a lot of very performance, peak performance, you got stateless, maybe a web application or something, the web tier would be fine on the top. You know, you can swing around a little bit. Hopefully, you'll have a light enough traffic load or enough nodes to be able to hit those peaks. But if you're looking for something more data-centric, you're obviously going to want to have a performance graph looking more like the bottom. So this kind of plays into proof for the importance of hybrid hosting with your application. So let's talk about some of the considerations with performance. And before we get into a little bit more about how we leverage these platforms, let's kind of talk through a couple of the various platforms that are available. Obviously, you've got your virtual instances. I think everybody's very familiar with these. This is, you sign up, spin up your instance. It's on a host somewhere. Like I said, typically found on the web tiers, those sorts of things. Things that you are going to need a lot of stateless nodes you can put behind a load balancer and be able to bring on and offline rapidly. They play very well in that space. Then we have bare metal. We'll get more into each of these. Bare metal is basically leveraging the same tenets of cloud, the scalable on-demand, high-speed deployments, APIs, those sorts of things. But instead of being a multi-tenant solution with a host that you may not know what kind of machine it's running on, it's an actual physical server. So we're putting an image rapidly onto a physical server, and you are single tenant and able to have access to all of those resources and have a little bit more customization options. If you need specific RAM or specific CPU profiles, you're able to get those along with storage. Maybe you need SSD specifically, or you're okay with spinning disk. You're able to make those decisions there on technology. And then obviously we get private cloud. So you're mainly focused there upon security type applications, or once again you're worried about that noisy neighbor effect. You want to know that you're the noisy neighbor and you're able to control when and where that happens. So this is just basic infrastructure, physical servers that you've had, either your provider or you've got yourself a bare metal server, and you've put together an OpenStack solution or something, and you're hosting your own VMs for yourself. Like I said, typically this lends to security and control. And then obviously one of the other differentiators across all these platforms is the storage. It started kind of as an afterthought for cloud, but more and more lately we've been looking at it as a key player in the space. The different sorts of storage media that are underneath of these becomes important, and it's important for you to know, am I on network attached storage? Do I have local disk? Do I have direct attached? Those sorts of things become important, especially with data-centric type applications. So that kind of plays into it as well. So one of the strongest components that has been coming through lately has been the network performance, latency. So as you're starting to put together applications that need to communicate across all these tiers, the network becomes very, very key. Network latency, throughput, the sort of topologies you can put together. I'll get into that a little bit, I think, on the next slide. I don't want to skip too far ahead, but being able to understand zones, the price per gig that you're going to pay, putting across those sorts of things become very important, what sort of latencies between them, like we said, as we evolve across that application evolution that I was showing earlier. And what we have here is we're talking about like port speed as part of that as well. So not just the latency between the data centers, but the port speed itself. Maybe you have a solution that you need Rocky RDMA across converged Ethernet or something. So the port speed becomes important as well, especially when you're doing replication, 3-layer architectures, things like that. This chart is actually showing, we have at SoftLayer, we do a 3-layer network architecture. We have our public side that we charge the traffic for. We have a private network, which is worldwide. We don't charge for that at all, the traffic on that. And we have a management one in case you get things so messed up you can't get to your server anymore. You can VPN and get to it. So those sorts of considerations are important to consider when you're dealing, like I said, on that far end, when you're trying to set up maybe an ecosystem or a larger scale application. The network does become very, very important. And I like this slide. I like to call it my birthday slide. Right after we were acquired by IBM, January 17th, which happens to be my birthday, I think it was a birthday present for me. They put $1.2 billion into our company specifically to improve our footprint with data centers and with the network, our network reach. So once again, as you're traveling across that, if you remember the evolution of the cloud applications, now we're talking about the Internet of Things, right? So you've got all of these points of interest with data being flowed into the network, and maybe you're pulling big data stats off of it, you've got sensors running, or maybe you've just got content that you're providing out to a global footprint. Being able to understand what the provider has as far as a global reach. Sure, you started in a single data center, but now you're needing to move out, you're wanting to cache things, you're wanting to leverage a CDN network. The reach of the network becomes very, very important. Also, I like this slide because it goes through and actually shows some of the options to increase the availability to end users at a budget. If you can find clever ways to maybe centralize your data and then cache it out to, say, Asia, or use the CDN, there can be some significant cost savings as to, as opposed to if you started an application locally here domestically, you don't have the ability to expand with your provider out into different regions and then having to replicate your deployment in those different areas. It can be a real mess to manage, and it's not very price performant as well. So then let's talk a little bit about a product we call Direct Link, but really all that we're talking about is the ability to sort of do a hybrid cloud. Let's say you've started with an application that you have hosted locally, and you're wanting to maybe burst into the cloud, something like that, or you've got a big data application that you have locally, and you want to move it off premise. It's very important when you're looking to move to the cloud that you find a good solution to be able to move off of your local installation onto onboard onto the cloud provider. So this is just simply, a way to get across the internet with some sort of guaranteed speed, a dedicated pipe of some kind between your site and your cloud provider. This is, like I said, great if you want to burst into the cloud, or if you simply just want to set up a replicated instance locally and then set up some other instances on the cloud. Great way to migrate onto the cloud. You can replicate onto it then and shut off your local instances and switch completely over to your cloud instances. Very handy for that. This was a product actually that we just came out with this year that I was killing to have out there. Every time I came to a conference, we had a lot of things we could do before, but now that we have a standardized product, it's a lot easier. And if you can look for that with providers, it will make moving onto the cloud or bursting an easier experience, much more pleasant for you. Scaling. It's important that when you get ready to scale, that you know how you're going to scale, right? You might understand when I reach these thresholds, I'm going to need to burst. I just got mentioned on Reddit, and a bunch of people tagged onto it, and they all love my product now. I've got this mass of people coming, right? You've got this huge influx of traffic. How do you react, right? Are you going to sit there and push the button on the UI? Is that what we're dealing with? Or do you have monitoring? Have you put the monitoring in place to be able to detect these situations? It's 3 in the morning, you're sound asleep. Your application just went big. So it's important to have that monitoring, have those abilities to be able to put together an auto-scale solution. So does the provider provide you tools to be able to detect that monitoring event and allow you to define how do I want to react? I just went dark on the West Coast. What's going on? I don't have any connectivity there. Oh, my provider's down. Okay, don't ask for more instances there. Ask for some in the central zone, those sorts of things. So there's a whole host of products out there that do this, as well as providers. So it's very important to be able to understand how you scale, how you do it rapidly, and how you monitor to be able to know when you're going to scale. And hopefully your provider can give these tools to you so you don't have to develop them themselves. Let's talk a little bit about bare metal. This was an excellent product that I really feel like SoftLayer embraced from the start. And when we're talking about this one, we're talking about, like I said, just physical servers. So one of the things that we embraced at SoftLayer early on was automation. And I had some really excellent conversations at a Cloud Expo maybe 2 years ago with some IEEE people. And it was mostly just a friendly debate about, is bare metal actually cloud? And the argument kind of came around, well, there's no hypervisor with bare metal. And does that mean it still is cloud? And I had argued that if you can rapidly deploy it and you can scale it, and you have an API that's the same backplane API that we use for our virtual servers, so you're not making a different sort of API call, you're still just asking to create a new instance, and you get it online very rapidly, it has images, it's repeatable, that means it's cloud. And I think the rest of the industry's finally caught up to that idea and is really now embracing the idea of bare metal as a true member of the cloud ecosystem. It's much better for data applications, and a lot of other people now are kind of jumping on to the bandwagon, right? So if you're wanting to run your database, OpenStack has come out with a new part of their application solution. Now they have the Ironic project, which once again, we're still talking about just rapid provisioning, same API as they're using for the regular OpenStack, same sorts of calls, look and feel. But now you get that single tenant solution, so you're on that server by yourself. You're not having to fight for resources. You don't have to worry about the guy that's DOSing, somebody that he doesn't like because he just spun up a VM next to you and now your website's having a bad day as well. Those sorts of things aren't going on anymore. You've got that actual physical server that's yours, known commodity, you know what its resources are, and it's built to your specification for your application. Like I said, typically when I see these, it's a big data application, a database, something where IOPS and network throughput are really, really important, and you don't want to be sharing those resources with someone else. That's key to the success of those type of applications. So you'll find this in a hybrid solution on the back end. Like I said, a lot of times it'll start as a premise deployed application. You've got a database, you're bursting up into the cloud, you've got your web tier in the cloud. Maybe you can roll it into the cloud then using bare metal to move it all into one centralized location. Also, Ubuntu with Juju, they have joined in as well. So now they have Metal as a service. There was an excellent IBM interaction with them, with joining with Ubuntu to put a lot of their products on Juju as well. So in addition to like your x86 or maybe your graphic GPU-based applications, IBM worked with Ubuntu to put out their power-based applications, things like that. So they have those platforms on Juju as well now, Metal as a service. So like I said, I think we're going to continue to see more and more players in the space start to move into the bare metal area and join in. So let's talk a little bit about design considerations. So we have several different kinds of applications that you'll find. Obviously, you've got app and web, which is mostly about metrics. You know, how many users do I have? What's going on? You know, what's the traffic footprint look like? Gaming, they're way more interested in where are you spending your money? Where are you spending your time? What happened when you quit? Why did you quit playing my game? Lots of metrics gathering there. Financial, computer modeling, predictions, trend analysis, those sorts of things, looking at what's going to be the next big thing to hit. And then obviously then you've got science, very similar kind of thing, broader scope of the data, looking into trend analysis, things within the data. So then some of the key design considerations. What makes scalability hard? Why is it difficult to pull this off? It's a design consideration. It's not something that you just throw more CPUs at or more storage. You really have to embrace the idea of, does my language, does my architecture actually allow me to be able to scale? You can't just take any application and throw iron at it. So then one of the key ways that you can actually leverage that is to focus on being stateless and asynchronous, right? If you kind of hold on to your state, well, then you have to replicate that state, and it makes scaling very difficult. If you're stateless and you just need to spin up a new node and it takes some small key piece of information and is able to recreate the state it needs to be able to work, that's great. Works extremely well. Being asynchronous, right? So you don't want to have a bunch of people waiting on a resource. Causes a bottleneck, causes a backup. You're not going to be able to scale well with that. Being able to hand off information and be able to have it asynchronous through reply is very key to that performance. And then as far as if you do get into asynchronous behavior, eliminating choke points, finding places where there are I/O bottlenecks, areas where your application is slowing down. Maybe if you can make those asynchronous to be able to free them up, free those resources up. Obviously, if there's some architecture or design flaws, get in there, being able to have the sensors and telemetry to understand how to remedy those situations. And then, of course, to expect failure. One of the big things about cloud, I love to talk about Netflix with this, expect nodes to fail, have a strategy, be able to recover from them. Very, very key to being able to architect an application that's going to play well on the cloud. Just try calling your cloud provider and say, hey, my instance went down. Typically their answer is, we'll spin up another one, or we'll bring it back up again. Very different than enterprise. You're expecting failure on the cloud. You should embrace it and be able to recover rapidly from it. So let's talk about a couple different architectures. Really quick, this is more of the web type architecture. So when we look at this, you've got sort of that web tier behind the load balancer. That's probably your virtual machines. You've got a caching layer beneath there, still probably virtual, just regular guest commodity cloud instances. Sitting behind it, you've got a database, most likely probably bare metal. And then you can see that ecosystem start to play into there. You've got some extra compute, object storage, CDN queue. These are those services that providers are starting to provide. And then let's talk about some more of a tricky one, gaming. I have a lot of friends in the gaming industry, and they're just now starting to embrace a lot of the cloud technologies. So you're looking at state replication here, understanding the metrics about it. How do I mine those metrics to generate more revenue? How do I keep people playing my game? Those are all very, very important there. Being fed into a big data application for analytics. This is a very common architecture for that we see for a gaming platform. So lastly, we'll talk about the future is now. So let's talk about some things that are coming up, some things that I see that we have coming through our labs that we're enjoying playing with. Linux containers is a great, great thing. If you haven't heard about these, basically we're talking about going without a hypervisor now. So being able to have a small contained Linux environment that allows you to customize it and not have a hypervisor tax. So you can have several of these running, just a simple service or application on a machine with all that security of being contained within that container without having to worry about a lot of the overhead of having OSs. And this is kind of talking to that. So if you look at some of the hypervisors that you had here previously, so you had a couple different type of deployments. Maybe you had just the hypervisor on the bare metal. Maybe you had an OS in between. But then when you look at the containers, you're sitting right on top of that operating system. It's part of the kernel. You're getting all that raw performance while still getting that containerization. Very, very cool. One of the leaders in this space right now that's coming out, Docker. If you haven't heard about Docker yet, it's an excellent container tool. They just went 1.0. It's the ability to be able to take that container and then move it from development to test to production. We have a presentation there, real quick link to that where you can go get more information. IBM did some joint presentations at DockerCon if you want to get more information about that. I would expect to see a lot of providers being able to provide you a container and moving into the container space as time moves on. So look forward to that. So every presentation needs a summary. Cloud adoption, so enterprise applications. Can't just move them into the internet space, can't just move them to cloud. There's key verticals for innovating into the cloud. We went over those. The key considerations, so what ultimately determines your success, it's going to be a lot about what you do with your application, how you architect it, how you deploy it, being able to understand the services your provider provides. And then the actual architectures themselves, we went through a couple of those. Being able to leverage stateless wherever possible, asynchronicity. And if you do have data-hungry applications, leveraging bare metal or hybrid deployments. And then obviously, the cloud is still evolving. We have things like containers coming around. So those are going to be an emerging technology that might provide some performance enhancements. Verdict is still out on that, so we'll see how it pans out. So thank you very much. Some contact information here. If you have any questions, I'll be at the SoftLayer booth throughout this entire conference, and then also my email address there. So thank you.